3 days. That's how long the Philippines had between a 6.9 magnitude earthquake killing 72 people in Cebu and Typhoon Paolo. On October 3, 2025, at precisely 9 a.m., the storm made landfall in Dinapigue, Isabela. Over 315,000 people found themselves caught in a cascading crisis. Welcome to Earth's dark secrets. I'm about to reveal how the Philippines' 16th tropical cyclone of 2025 struck when the country was most vulnerable, turning what meteorologists classified as a manageable typhoon into a humanitarian crisis, where timing became as deadly as the storm itself. Understanding Typhoon Paolo's devastation requires rewinding to September 30th, 9:59 p.m., when a 6.9 magnitude earthquake struck offshore near Bogo City in Cebu province, 700 kilometers south of where Paolo would eventually make landfall. The quake killed 72 people, but that count was only part of the damage. The earthquake fractured the Philippines' national disaster response infrastructure at the worst possible moment. Emergency crews, rescue equipment, medical supplies, and coordination personnel were concentrated in central Visayas, conducting search and rescue operations in earthquake-devastated communities. Then meteorologists detected a tropical disturbance organizing 800 kilometers east of the Philippines, managing active earthquake response while simultaneously preparing for a major typhoon striking a completely different region. Resources couldn't be in two places simultaneously. Every helicopter deployed to Cebu was one unavailable for potential typhoon evacuations in Luzon. Typhoon Paolo, internationally designated Matmo, emerged from the Philippine Sea with concerning characteristics. By October 2nd, the system had organized into a severe tropical storm with sustained winds approaching typhoon threshold. But Paolo wasn't finished evolving. As the storm approached Luzon's northeastern coast, warm sea surface temperatures provided exactly the energy needed for rapid intensification. The kind of explosive development that gives forecasters nightmares because it leaves minimal time for adequate preparation. At 8 a.m. on October 3rd, just 1 hour before landfall, Paolo officially intensified into typhoon status with sustained winds of 130 kilometers per hour. The storm had saved its final transformation for the last moment. Pagasa raised tropical cyclone wind signal number 4 across 10 provinces in northern Luzon and Aurora, the second highest warning level indicating life-threatening wind conditions. 9 a.m., October 3rd, 2025. Dinapigue, a coastal municipality in Isabela province where fishing communities had spent the night in reinforced structures, experienced Paolo's eye wall making direct landfall. The town's location amplified the storm's destructive potential, positioned exactly where Paolo's spiral bands concentrated their maximum power against a narrow coastal plain squeezed between the Philippine Sea and the Sierra Madre mountain range. This geographic configuration created a natural wind tunnel. Paolo's already powerful winds accelerated through the constricted space between ocean and mountains. Sustained winds of 130 kilometers per hour slammed into communities across northern Luzon. The storm's minimum central pressure of 975 hectopascals indicated an intense, compact system, the kind that delivers concentrated destruction rather than spreading its power over wider areas. Dinapigue didn't experience gradual intensification. Residents went from relative calm to maximum typhoon conditions within the span of the eye wall's passage. What happened next reveals why northern Luzon's topography becomes a hydrological weapon when typhoons strike from specific angles. Paolo crossed the Sierra Madre Mountains, a 540-kilometer spine of peaks rising to 1,800 meters that forms Luzon's eastern backbone. Normally, these mountains weaken typhoons through friction and disrupted airflow. But Paolo's trajectory cut perpendicular to these ranges, maintaining the storm's coherence while forcing its moisture-laden air masses upward against the steep terrain. This orographic lifting triggered extreme rainfall. The Cagayan Valley, northern Luzon's agricultural breadbasket, sits directly downstream from these mountain slopes. As Paolo's moisture was wrung out by the topography, the resulting rainfall accumulated in valleys with limited drainage capacity. Farmers across Isabela and Cagayan provinces watched flood waters rise, not from rivers overflowing their banks, but from rainfall accumulating faster than saturated soil could absorb. This pluvial flooding is particularly dangerous because it occurs rapidly in areas not traditionally considered flood zones, catching residents in locations they believed were safe from water-related hazards. The same mountainous terrain that makes these provinces agriculturally productive became a disaster multiplier during Paolo's passage. By mid-morning October 3rd, northern Luzon's infrastructure was experiencing systematic failure that revealed vulnerabilities in systems designed for normal typhoon parameters. Power outages darkened communities across Cagayan Valley as transmission infrastructure collapsed under Paolo's sustained assault. Trees that had stood for decades crashed through power lines in Tuguegarao City. Water pumping stations stopped operating. Communication towers lost backup power. Road networks became impassable throughout the affected region, not from simple debris blockages that crews could clear within hours, but from fundamental structural failures. Floodwaters undercut road foundations, causing entire sections to collapse into newly formed ravines. Bridge supports weakened. Over 315,000 people affected. 8,380 people displaced from homes that sustained damage, rendering them unsafe for habitation. One house completely destroyed, reduced to its concrete foundation. Another 26 sustained major structural damage, requiring costly repairs before families could safely return. 6 critical infrastructure installations sustained damage. Facilities that served thousands of residents suddenly rendered non-operational. These big numbers cannot capture longer-term consequences. Children missing school weeks, businesses shuttered indefinitely, agricultural cycles disrupted in ways that would affect food production into 2026. As Paolo exited into the South China Sea on October 3rd evening, the storm maintained typhoon intensity over warm ocean waters, beginning a track toward China's Guangdong province, home to over 126 million people and economic centers including Shenzhen, Guangzhou, and Hong Kong. Chinese meteorologists monitored Paolo's approach with concern, informed by the storm's Philippine performance. The typhoon had demonstrated its capacity to exploit geographic vulnerabilities and maintain destructive power longer than forecasts initially predicted. The timing compounded China's challenge. Golden Week holiday had millions of citizens traveling across Guangdong province, complicating evacuation logistics and emergency coordination. Paolo approached when population distribution was maximally dispersed and unpredictable. By October 4th, Paolo was churning toward Macau and western Guangdong, with sustained winds still exceeding severe tropical storm levels. The system that had already proven its destructive efficiency in the Philippines was about to test China's typhoon defenses during peak holiday season. Another example of how natural disasters seem calibrated to strike when societies are most vulnerable to disruption. Typhoon Paolo exposed a reality that disaster management systems rarely acknowledge. Modern emergency response infrastructure isn't designed for simultaneous, geographically separated catastrophes. The protocols work brilliantly when addressing one event at a time. They fracture when an earthquake deploys your resources to central Visayas 72 hours before a typhoon strikes northern Luzon, forcing impossible decisions about which disaster receives priority attention. Over 315,000 people affected by a storm that wasn't even the Philippines' most powerful of 2025. Entire regions without power or road access, not from inadequate preparation or institutional failure, but from a disaster sequence that exposed fundamental limitations in systems designed for sequential rather than simultaneous crises. 3 days between earthquake and typhoon, enough time to track Paolo's approach and issue warnings, but insufficient time to redeploy the resources already committed to earthquake response 700 kilometers away. The Philippines discovered what happens when disaster timing becomes as deadly as the disasters themselves. When your emergency response capacity is already exhausted before the next catastrophe makes landfall. As climate systems continue evolving and tectonic activity remains unpredictable, the question emerges: how do we prepare for disasters that strike not in isolation, but in sequences specifically calibrated to overwhelm our capacity to respond? The answer, as northern Luzon discovered on October 3, 2025, might be that some scenarios exceed current response capabilities, regardless of early warning sophistication or disaster preparation investments. Sometimes the Earth doesn't wait for recovery before delivering the next blow. And sometimes 3 days isn't enough time to be ready for what's coming. Thanks for watching Earth's Dark Secrets, where we expose the hidden realities behind our planet's most devastating disasters. If this investigation revealed something the mainstream media won't tell you, please like, comment, and subscribe. Your support helps us uncover the stories that authorities don't want told. Hit the bell so you never miss our in-depth analysis of the disasters that reveal our planet's dark truths.